Our definition of combination, we have to recall it. Recall, we have to recall it. Recall n combination r equal to n factorial all over n minus r factorial r factorial. So if we are going to apply this to get our coefficients, so they are very simple to apply. So that means we by applying that in this expression, we have 2 minus 1 over 4x raised to power 6 equal to, now 6 combination 1, that's going to be 1. So by applying this formula, so in order not to waste time, we have to do that. So this combination 0 is going to give us 1, and 2 raised to power 6 will give us 64. That's 1 times 64 times, so everything here. So since it is raised to power 0, that will give us 1 plus 6 combination 1 by applying this formula will give us 6. Then 2 raised to power 5 will give us 32 dot this is minus 1 over 4 raised to power 1. We are still going to have our negative minus 1 over 4x, so raised to power 1. Now the next term will follow. So 6 combination 2 by applying this formula, 6 combination 2 is, let's work it out somewhere. 6 factorial all over 6 minus 2, which is 4 factorial times 2 factorial. That will be 6 times 5 times 4 factorial all over 4 factorial times 2 factorial. These are gone. So this is going to give me 15. 6 combination, that means 6 combination 2 is going to give me 15 times 6 combination 2 times 2 raised to power 4, which is 16, times minus 1 over 4 raised to power 2. So this, since the power is even, it will affect this sign and become positive. That will be 1 all over 4 squared, which is 16x raised to power 2. Then the next thing follow 6 combination 3. 6 combination 3, you can quickly simplify down. 6 factorial, 6 minus 3. By applying this formula, 6 minus 3 will give me 3 factorial times 3 factorial. Then we have 6 times 5 times 4 times 3 factorial over 3 factorial times 3 factorial. These and these are gone. So we have 3 factorial and 6 are gone. 5 times 4, that will give me 20. That means this combination 3 is going to give us 20. Now 2 raised to power 3 is going to give us 8 times negative. So the power is odd here. The answer will be negative. That's minus 1 all over 4 x raised to the power of 3. So the next term will follow. 6 combination 4. 6 combination 4 is also going to give us, by applying this formula, it's going to give us 15. So that's 6 combination 4, that's 15 times 2 raised to power 2, that's 4 times negative of this, that's minus 1 all over, oh excuse me, raised to power 4 will be positive, power 4 will be positive, that's 1 all over 4 raised to the power of 4, that's 4 times 4 times 4, that's 4 times 4 times 4 times 4, that's 64 times 4. 64 times 4 is going to give us 216 x raised to the power of 4. Now, followed by the next term, 6 combination 5 is going to give us 6. So that's 6 times 2 raised to power 1, which is 2 dot times 1 all over 5 raised to power 4. That will be 216 times 4. 216 times 4. 216 times 4, that's 856. That will be 856. But negative answer 1 over 856 x raised to the power of 5. Then the last part of the question, that's 6 combination 6. 6 combination 6 is going to give us 1. That's 1 times 2 raised to the power 0 is 1 times 1 minus 1 all over 4 raised to the power of 6. So that's 8 5, the denominator 856, that will be 856 times 4, which is giving us 3424. 3424. Oh, excuse me, that's 1 all over 3424. 1, it's going to be positive because the power is odd. 1 all over 3464 x raised to the power of 6. 3464 x raised to the power of 6. Now, we are going to simplify the terms for that 3424. Excuse me, 3424. So we are going to simplify the powers. We are going to simplify the terms to get our final answer because we said the question says we to simplify. We have to simplify. It is necessary to simplify. Now, 1 times 64 times 1. So we have to combine these 2 minus 1 all over 4x all raised to the power of 64 to 1 times 64 times 64. That will give me 64. The next term followed is going to be negative because plus times minus will give us minus. So we'll be having 6 times 32. So we can reduce this. 4 can go here once, and 4 can go here 8 times. Then we have 6 times 8, which will give us 48 x raised to the power of 1. The next term follow. So 16 can cancel 16 here. So we have 15 x raised to the power of 2, which will be positive. Then 15 x raised to the power of 2. Then the next term automatically will be negative. The next term automatically will be negative. So 4 can go here. 4 here 1, 4 here 2. So we have 20 times 2, which will give 40 x to the power of 3. So the next term automatically will be plus, will be positive. So we have 15 times this. 4 can go here. 4 here 1, 4 here 64. So over here we can place 15 all over 64. 15 all over 64 x to the power of 4. So we continue like that. Continue like that. Oh, sorry, the next term is going to be negative. The next term is going to be negative. The next term is going to be negative. So we have over here. So 2 can go in this. 2 here 1, 2 here 4, 2 remember 1, 4, 2, 8, and 2 can still go here. 2 here 3. 2 here, 2, 1, 4. So we can place 3 on top of 2, 1, 4. That's 3 all over 2, 1, 4 x to the power of 5. And the last term will be positive. The last term will be positive. That's 1 times all of these. That's 1 all over 3, 4, 2, 4 x to the power of 6. So this our last expression is the given binomial is the required binomial expansion in the simplified form. So we are done with the binomial expansion. For the question, we are not done with the whole of the question. The question is still asking us to use this expression to get the value, an estimate value for 1.975. So let's write it out. 1.975 raised to the power of 6. This can be written as 2 minus, if we write 2 minus 1.975 to know what you can subtract from 2. 2 minus 1.975. That means we have 2 minus 0.025 to give us 2 minus 0.025 is the same thing as 1.975. And this is what we are going to expand. But before that, we still have to get what we are going to take as our x. So by comparing this and the given question, to compare this and this, we can get a value for x. So we can say that 1 all over 4, comparing, by comparing, by comparing, by comparing, to compare this and this, we are going to see that 1 all over 4x will be equal to 0.025. So by cross multiplying, then x will be equal to 4 times 0.025. 4 times 0.025. So we have to multiply that. 4 times, this times 4, that will give me 0.1. So that means my x is 0.1. So now, this is what I am going to substitute for x in this expression, which will lead me to my required answer. So I can now use this inside this expression. So that means 1.975 raised to the power of 6, which is the same thing as 2 minus 0.025 raised to the power of 6, will be equal to 64 minus 48 brackets x. Anywhere I see x, I'm going to be putting 0.1. 0.1 plus 15 times 0.1 raised to the power of 2 minus 40 bracket 0.1 raised to the power of 3 plus 15 all over 64 0.1 raised to the power of 4. Now, if you look at this 0.110, we see that the number figure 0.1 is a small number, a small number. And if we have a small number like this, the higher the power, the smaller it becomes. So we can always neglect the remaining power after this. After the fourth one, we can always neglect the remaining power. So we can simply simplify this so that we can get our answer. So we have 64 minus 0.1 times 48. That's 1 over 10 times 48. That will give me 4.8. Plus this also 0.1 raised to the power of 2. That will give me 0.01. 0.01. That will give me 0.01. That's the same thing as 1 all over 100. Same thing as 1 over 100. And 1 over 100 times 15, that will give me 0.15 minus 0.1 raised to power 3. That will just be 1 all over 1000. That's 40 all over 1000, which is the same thing as, so, which is the same as 0.040 plus 0.1 raised to power 4. That's going to give me 1 all over 10,000, which is 15 all over 64 times 0.0001. No, excuse me, 1, 2, 3, 4. Yeah, 1 over 10,000. That's what we are going to have. So we have to compute, so we can neglect the remaining terms and so on. So we have to compute a value for that. So we have 64 minus 4.8 plus 0.15 minus 0.040 plus 15 times 0.0001 divided by, as 15 times 0.0001 divided by 64. That will give me 0.000234 minus and so on. So this is what we are going to simplify to get our values. So we say 64 minus 4.8 plus 0.15 minus 0.040 plus 0.0000234, and then compute this. That will give me 59.3100234. Now, we now come back to our original question. The question says we should leave our answer correct to 4 significant figures. So, this is the first significant figure, second, third, and fourth. We look at the next digit after it. See that 0, which will be rounded down to 0. 0 plus 1 will give me 1. That's 59.31. So that's approximately what the given expansion, the power of 1.975 raised to power 6 is going to give us 59.31. And if we use our calculator, we are going to get the same thing. So this is the end of the question. Done.